everyone. I think it's time to get started. I'm Mark Groot, Customer Success Manager at the Software Improvement Group, and I'm the host for today. And with me, I have a very special guest, Kriti, who's going to talk about, and you can go to the next slide, a very important topic, modernizing architecture, more than just legacy rebuilding. And yeah, with that, Kriti, over to you. What are you going to talk about?
Yeah, thank you. So I'm going to start with my storyline, but before I do, I just want to set up some scene. So we have been working with different organizations for a long period of time, and we see sort of a shift. If we talk about traditionally how the way these software companies were designed, it was mostly management who would decide what and how to do, and the development teams would execute it. Now, this is the model where we say the developers are not really empowered. They are, let's say, they're not happy because they are just following the orders that comes from the above. And that was a time where we saw the culture shifting to agile, right? So people wanted to fastly build something, put it out on the market, fail, and then re-strategize as to which direction they would like to go. Now, this is where the development team sort of own the process, and they are the ones who decide how should things be run. Now, in this case, the management gives basically the full autonomy to the development teams. But what is the downside of this model is that they sort of lose the control because they don't know if the management wants to go into a certain direction, the development teams have their own view, and then again, we are sort of in a trap. What has actually worked well, and that's also something that we see most of the organizations that we interact with today following, is the hybrid model, where management decides what. So they decide, for example, key topics to their business can be technical debt, security, or architecture, and the development teams have the autonomy to decide how they can execute this in line with the policies that have been set by management. And this is basically best of both worlds, where the developers have the autonomy, the management has the control, and this is sort of the combination of the two. And that's where we sort of saw the role enterprise architects emerging, because they sit in middle of the two. They sit between the business people, and they sit between the technical people. So they are half technical, half businessy, and they sort of want to steer this. They would like to help the development teams execute something which is in line with the management. So now that you see, the architecture quality model that we have designed is keeping enterprise architect in mind. That's why it's there in the name itself. But then the question is, for whom is the architecture quality model designed? Is it just for the enterprise architects? Well, yes, that's sort of our prime role that we are targeting. And that's also because it's already in the name. But what does this role actually encapsulate within it? What we have seen also now in the organization and talking to a lot of people, architect role is still abstract. There are companies where this role exists with the exact title, but there are also companies where this role is executed by a technical lead or by a lead developer. Now, ideally, if you look the way the companies are structured today, when we say we are targeting enterprise architects, we do not just mean the role itself, the name itself, but we are also targeting people like technical leads or the lead developers, or as you mentioned in one of the poll questions, there could be developers as well. So how do you draw the line between architectures and developers? So with architecture quality model, we are targeting everybody, all these roles. So just don't go by the name. But the idea of having all these three roles is that the core responsibility in terms of architecture is to make sure that the high level design of the architecture is flexible and is future proof. So this is their end goal, irrespective of what is the role called. It can be a technical lead making these decisions. It can be a lead developer. It can also be the title of architect themselves. But now, if we look, what is their mindset and what's the challenges? Now, if we look at this, I'm going to use this picture for architect and I'm going to combine whatever we have talked about. It can be architect, it can be a tech lead, it can be a lead developer. So any of these people, the mindset usually is that these people, as I said, want to build something that's future proof. Now, in that setting, they would not like to be behind the development teams and sort of own them. They want to be a coach rather than being a policeman. So they definitely do not want to be the police and just being behind the development teams. And that would also defeat the hybrid model, because that's where the development teams wants more autonomy. But what they want is to be the coach, sort of steer the development teams in a way that the high level policies that the management team is setting, that they can steer it with respect to those policies. Now, the architects wants to make their own decisions, but they also do not want to be the police, and they somehow want that the decisions they are making are in line with the long-term goals which are set by the management. However, that might sound easy. That's quite a hard task for the following reasons. There is a lot of things going in the development team. So architects or technical leads or lead developers are usually short on time, and then the question becomes, how do they capture whatever is going in the architecture right now? And that's where a documentation comes in handy. So they should know when's the documentation ready. And I think that's sort of a good moment to also fire our second poll, just to learn from you all, because at least from my assumptions or from the people that I've interacted with, I've I've received mixed answers on if people actually maintain architecture documentation.
Yeah, so good question. So I think the poll question that we have for you is, do you have your architecture well documented? And I've had the pleasure to talk about this topic with customers as well.
Mm-hmm.
And we know this is hard, right?
Mm-hmm.
Because the moment that you kind of put something on paper, it's already outdated. So is that also something that you see, Kriti?
Yes, that's true. And I think that's also my following question. So I'd like to hear if people are actually documenting stuff. And if yes, can they keep it up to date? Like up to date every time there's a new release? Is your documentation up to what it looks like now in your implementation?
Yeah, I see that most people have answered. So I'm gonna give like 5 more seconds,
Mm-hmm.
and then we can go to the answers, because this is one I can share, and
Mm-hmm.
I think the answers are interesting.
Mm-hmm.
I'm not sure they're surprising, but I think they're interesting. So I'm going to share the results, and you should be able to see the results now. Yeah, and like an overwhelming majority does not have their architecture well documented.
Yeah.
And how big of an issue is this?
That's, to be honest, that's an issue that I've seen. Like it is a big issue that people do not have the architecture documentation. And even if the people have the architecture documentation, keeping it up to date is really challenging. It's like now with Agile, you make a release yesterday, you add a few more dependencies, few more components that you add, then how frequently do you change this picture?
Yeah, and I guess it also has to do with people it now lives in people's heads.
Exactly.
But they might change roles, might change organization. So yeah, I think a second poll question, a third poll question that immediately comes after this, I'm going to launch. I first need to stop sharing the other question. It has to do with indeed the upkeep of it. So is the architecture documentation kept up to date? Obviously, for the ones that said that they don't have a document, well, obviously there's no document. But indeed, I think that like keeping it up to date, I think that's where the real challenge is.
Yeah.
Because it's really like one of those like black holes that you can spend time again, like hours on. So interesting to see if people have that under control.
I would be curious if people answer this as yes.
We'll see. Those are the customers that we need to put on the stage, right?
Yeah. And I mean, to be honest, I would like to just look into the kitchen and see how they're doing stuff, keeping this up to date.
Well, let's see. Okay, I'm gonna give it 3 more seconds, because then it's 1 minute, and poll, share results. So we do have some people that have it kept up to date.
Yeah.
So yeah, maybe that is something that is like those customers we can bring on a stage at some point.
Indeed, that's an example, ideal example to be shared.
To share their best practices.
Exactly. But I mean, these results are in line with what we have seen generally. I mean, people find it hard, A, to document stuff, B, if the documentation exists, it's hard to keep them up to date. And that's exactly where Sigrid can help you. So Sigrid helps you visualize the architecture for you. Now, this visualization is automatically generated from the code itself. So you just have to publish your code and it is there. Now, the way it can help you is, we have seen in the industry that documenting architecture is not an easy thing. Now, if it exists, keeping it up to date is the another challenge that you face. Now, Sigrid itself allows you to be your live documentation, because every time you, let's say, make a change to your code and you publish that code to Sigrid, the visualization is also updated. Now, this reflects the picture that you see in Sigrid reflects your current as is architecture. And this can be sort of a medium to communicate within the teams. Because as Mark was saying, most of these decisions live in an architect's head or a lead developer's head. They know this is how they designed it. But when it comes to visualizing it, they are also sort of surprised sometimes to see some components which they did not expect, but in the visualization they see it, and they use this visualization as a communication device to just have a discussion with the team. So this is sort of the first thing, why are people using architecture quality. Now, the second thing why it helps you is Sigrid allows you to track changes in the architecture. Now, let's consider this is your architecture picture, just like I showed you before. Now, what can Sigrid also show you is if there's, let's say, a new dependency. So for before, there was no dependency, direct dependency between a profile and a recommendation. And let's say today you make a merge to it and it appears, then Sigrid would show you distinctively that this is a new line, like this is a new dependency from a component profile to recommendation. This way, it's easier and faster for the architects to keep track of what's going on. They're anyway busy. They do not want to go into teeny tiny details, but they would like to know how is the architecture evolving. And if there are any surprises, for example, let's consider this new dependency that was added is not in line with architecture, the architect role's expectation. And when I say it's not in line with the expectation, there's no right and wrong. It's more like there might be, this is not something that the architect planned, but now as part of the implementation, when the person sees there's sort of a dependency from profile to recommendation, that sort of warrants that architect role, that there might be some further investigation that's required. And now the investigation can be that this is a suitable thing. It's fine if we have a dependency from profile and recommendations. And if that's so, then again, Sigrid is being used as a communication medium. If, let's say, the outcome of the discussion is that this particular dependency is actually undesirable, we don't intend these two components to talk, then what Sigrid also allows you is to make this dependency undesirable by highlighting that in red. This is something that you can configure it. Now, this is apparent to all the teams, because why do you need to turn this red? It might be it's just one dependency that you can just remove overnight, and then you don't need to configure it at all. You can just remove it. But usually when a decision like that comes into place and you finally come to a conclusion, okay, this is an undesirable dependency, you would need to change a few things before you can remove this dependency. And that would take for probably a sprint, more than a sprint, can take multiple sprints. And during that time, because these development teams are autonomously working, it might be someone adds more code into it and adds more lines to it. So to make it apparent throughout the organization to the teams, like this is not the way we want to go, the Sigrid allows you to put that as red so that it's clear to the team that this is something that we do not desire. We do not want to add or have these two components talking to each other, we probably want to go via other route, for example, through commons or whatever the team discussions take place. So that's sort of the second reason why people are using architecture quality. And the third one, which is it helps you guide your architecture evolution. Now, it might be that, there's this small application that you're maintaining, and now you make some changes to it. So as your architecture evolves, as it becomes more complex, the architecture metrics that we measure warns you, hey, your coupling is increasing. Maybe for scalability, that might be an issue. We see the database being added, but then the single database is used by multiple components. Maybe you want to add more databases. So you see some warning signs, which again is sort of a warning that, hey, am I going the right path? Should I do something differently? So it helps the architect role to perceive these warning signals and to make a decision that's based on, okay, what are the metrics trying to show me? So these are sort of the three main use cases. Why should you use architecture quality?
So I have a question from the audience. And it kind of has to do with the last point, but it was already shared, like the question was already asked on the slide before. So it has to do with, I'm trying to rephrase it a little bit. So if the system grows, obviously, like it becomes a little bit more complex to really understand, like, hey, which new flow, which new calls between components get added. How to manage essentially this architecture and keep an eye on kind of these new type of dependencies being and these new type of calls being made. How to do that for a large system or a number of systems?
Yeah. So first of all, I think when the system becomes really large, it's obviously complex to see where things are changing, because things might be changing in multiple areas. The idea is to have something on the high level approved. As long as on the top level you approve of things, then you can take a section and say, this is, let's say, my engine, and in my engine I have 10 components, and I want to see how are they behaving and how are they talking to each other. If it is a small system, it's generally easier to start playing around with things. With large systems, what you need to do is you need to isolate certain areas and see what are the changes happening in my engine, in my front end, in my back end, and things like that. And then you sort of divide this and then reflect how metrics are changing there.
And Kriti, correct me if I'm wrong, because you have much more experience and knowledge on this than me. But what I believe is that we also show in which part of the system the teams are actually working most, right?
Yes, indeed.
So what I can imagine, especially for larger systems, there is a good chance that there's a whole bunch of kind of the systems or the components that are barely being touched, that are just kind of in maintenance mode. So then I can imagine it's also easier to kind of keep the focus mostly on the components which are changing most, right?
Yeah, that's true. So with component freshness, you get the view which are the, let's say, the areas where changes are happening the most.
Yes. Are you going to show that in the? Yeah.
Yes, indeed.
Perfect. Okay, then no further questions.
Okay, I'm going to stop sharing for a while and then just switch my screens.
Yeah, and as I said before, if you have any questions, do feel free to use the Q&A option on the bottom. Just like the person that asked the first question. If you have at some point any questions, do feel free to let us know, and we will include them into the story. And
please bear with me because I have a sore throat, so I might just have to give some signals to Mark to take over. But okay. So when you enter into the portfolio, this is the portfolio level. And if you're trying to find architecture, this is where you can find it. Now, if I switch boards, this is where you see the star ratings of your portfolio. But what you not yet see here is how does the component look like? That's also partially because our architecture quality model is designed to be at a system level, not at a portfolio level. So if you have, let's say, a portfolio where the systems are also talking to each other, which means the landscape view that you would like to see, We can't currently show you that at a portfolio level. For that, you still have, if you want to see that, you would have to configure all of these systems, all of these applications as component to a system. But for now, what we have is you can sort of go into a system and see how these are talking to each other. So in my example, I'm going to take Git.
And while you're navigating to that, we got another question from the audience. Does the visualization of architecture depend on the programming language?
No. So we work with the directory structure. We just take the top level components. So top level in your directory as top level components for architecture.
But and I can be wrong here, but obviously with Sigrid, we support over 300 languages. Do we also support for all of these 300 languages the architecture view?
So we support for most common ones.
Yeah.
There are some technologies in these 300 list, which the architecture would appear, but we might miss on some dependencies because let's say our architecture model is not mature enough for all the 300 technologies. But for the common ones like Java, Python, C, the ones that we see usually, for that, the architecture quality is good enough. Like it's quite mature enough for those. But if we talk about COBOL, might not be.
Hope this answers your question.
So then we are at the system level now, and I'm inside, as you can see in the top bar, in a portfolio inside the system Git. And here architecture actually pops up in the top panel. You can either switch it from here, from overview to explore, or you can just click here. And then we reach in the architecture section. Now this section is just like maintainability. So if you're already acquainted with maintainability model, this should be easier to get. What it shows you is that system Git scores 2.3 on a benchmark rating. This is the benchmark, and this is where it stands. The average is 3.0, and this particular architecture stood in a benchmark below than an average architecture. If we look, what are the all metrics that we are measuring? This is the list of metrics that we measure for architecture. And we basically on a high level look at the structure, how does it evolve? How is the communication between components? If there's a database, how is that database accessed? Knowledge, which is, we also look at how many people are working on a component. So is there a knowledge risk? What if there's just one person working on a single component and this person leaves? Then it means that we might be at a knowledge risk. That's sort of what it shows. It shows per metric what is the rating. Now, if you see how is the structure for this architecture, it's 2.7, close to market average. And it is basically the aggregation of these metrics highlighted in the blue. It's an aggregation of code breakdown, component cohesion, code reuse, and communication centralized. So if you hover around others, the others would highlight the same thing for you. So this code that you see here is coming from the aggregation of the ones that are highlighted in the blue. Now,
I do see a few that have an NA.
Yes, and that's a good question to ask. NA means not applicable, and why it's not applicable. So the last three ones, which is bounded evolution, knowledge distribution, and component freshness, they are calculated or they are measured from your history. If you're, for example, using Git, then it's calculated from the Git history. If you do not provide us the Git log file, we are unable to capture these metrics for you, and then it will be shown as NA. Data coupling, as I said, it is attached to a database. So that application must have a database. If it doesn't have a database, that means the metrics does not apply to you. So that means when we are calculating this rating, which is 2.3, this is right now the sum of these metrics, which is basically 5 of them. And we are not keep taking into account the rest 4. But if you provide us the data for all those, then it will be sum of all these metrics. Okay, so this is just some numbers. It also shows you some deltas, and the deltas are attached to whatever you select in the time period. Now, as I said, you are able to track changes. So if I put this year to date, you see some deltas here. You see some things that are stable. Coupling has gone a bit up. communication centralization has also improved a bit. So if I go into the explore architecture button, this is where I land. Now, if I look at this visualization, so this is basically the top level directories. It is automatically detected. There's no configuration that's gone behind. We just put in git, the source code of this system git, and this is what Sigrid populates. Now, this is a high level architecture where there is a group of some files. There are some small components, which are these, and there are also some independent directories, which are basically which have some files, but they do not depend on other components. So this is the top level architecture. Now, with architecture quality, you can go inside these files. So you can go inside these components. So if I go into this xdiff folder, these are the files that it has. And then you can also see how these files are talking to each other. So you can basically go until the file level. If I open, for example, another one, again, in most of, let's say in this architecture, you have references, and then in references is basically has some files. And again, you see where these arrows are and where these are talking. Now, if I zoom in a bit, what you also see is, for example, there is an arrow from reference to files which exist, but it is shown in a different color and is shown with the arrow up. What does it mean is between this period, 1 Jan to 28th May, there has been increase in the number of dependencies between reference and files. Or let's say, on the other hand, this the arrow that goes from reference table to the files has gone a bit down. So the dependencies from reference table to files have gone down, whereas dependencies from reference to files have increased. So it could be in this architecture that this was an old component. Maybe we are trying to get rid of it, and this is a new one that we are replacing it with. That's why most of the functionality that's in the reference table, we are moving to the references. And therefore, this line is bound to increase because that's sort of the decision that we have made. And this reference table to files is decreasing because we are sort of moving that functionality to the references. So when you make such decisions, which is basically on a low level, small scale modernization, it's not a big bang project, it's a small component that might be old, that was structured in an old fashioned way, and now you want to modernize it, you want to make it more isolated. This is probably a way where you can track changes. You know that you have shifted these, you would expect these dependencies from reference to files to grow and from reference table to files to be less. Now, this is on a high level. I see some questions. Yes?
There are some questions. So I'm going to start with the first one, and then maybe the second and the third as well. So the first question is quite a long one. How to manage the common component between front and back end, like data transfer objects. And this is a question we get a lot, and it's a catch-all. Like if we use common components to use DTOs in front end and back end, then it shows more component coupling and component cohesion. However, if we separate them, there's duplication. So how to provide that balance between
Yes. So first of all, with common, we do understand the fact that its name is common. It is bound to have more coupling, and it will have a strong communication. Let's say it will have a low score for communication centralization. This is something that we, even as SIG, we agree to this part that this is the case. Can we change something in our model? We would not like to, but the reason why that's the case, if you look, as I said, the ratings that show up at the top, they are an aggregation of all the way the components individually score, and also what is happening in the beneath layer. So right now, if we look, 2.3 is aggregation of how all of these components get a green or an orange or a yellow, and also including what's below. So what's beneath, how are these files behaving? So when we sum up these whatever is happening a layer below and at the same layer, we get up to this rating of 2.3. Now, there's a reason, and when you see there might be some, let's say some components which are in orange. That means there the coupling is higher, and there are others which are green. And when we aggregate them, they sort of balance each other. Now, the idea is on a top level, your rating should be 4 stars. So as long as you're doing better, above than the market average, you're doing better than how the industry is doing. So having commons in red is fine as long as the other components in your architecture are isolated, are more in green, or in, for example, in yellow. So having that one component in red can be okay, because when it will be aggregated up in terms of volume and in terms of star rating, it will have a very little effect on the overall rating.
Yeah, no, I agree. And I think one of the things that I've seen other companies do is also create a shared library.
Yeah.
So if you have a shared library that contains common DTOs and other shared components, and then they can be used by both the front and the back end.
Yeah.
And then you kind of reduce the code duplication and you increase consistency. Obviously, you do have more calls. So you need to see like if that makes sense for you. And yeah, what I've also seen one customer doing is use GraphQL.
Yeah.
To implement GraphQL to define those data structure queries.
Indeed. So there are multiple ways how you can deal with it. There's no one, let's say, one solution that can fix this thing. But we do understand, even with a maintainability model, as you would see, the metric sometimes tries to go against each other. And the goal is to find something in the middle. So even if, there's duplication that probably is hurting because of, I don't know, there's another metric which is component independence, and they now are competing each other. The idea is to find a decent value where both of them sort of remains at market average, whereas the overall score is above market average. And that's something that's achievable.
Yeah. Then another question. I hope this answers the question. These overviews look quite messy for our projects. If I move the items to get a better overview, can the placement be saved for the future, or will it be reset the next time I open this view?
Yes, that's a good one, and that's probably something I'm not sure if people know. We actually released a saved views panel. I can imagine when people start to work with architecture quality, and this is a lot clumsy, and you're working with it and you invest time to make a picture, for example, that's more visually appealing and is easier to read, and you have invested time and you want to save it. What you can do is, once you have rearranged stuff, what you can do is you can save this view. So you can save your current view, name this something. What will happen is it will just freeze those things there. And every time you open it, for example, I can say, this is my view. So you see the name who saved it. And then if you want to come back it again, so if I just refresh it, go to my saved views, it will go back to what I selected. So this is how I just changed it. So this is a way to save your view. If you have done some, and this can not only be at the top level, but let's say if I open something, just give me a second.
I do have some more questions, by the way. So I see that,
in the meantime,
I see that people are really.
Yeah, I know what happened. I did something.
I see that people are really, getting loose with the questions. So in the meantime, also, while you show this, can you turn off one of the metrics? Okay, for example, the knowledge distribution. If yes, how?
Yes, so that's also something that you can do. So for example, as I was saying, just to close the previous question, you can save this view here. If you go inside one of the component, you can also save this as the next view. So it really depends. And then you just have to give that view a name so that you remember it.
And then how do you get to it once you kind of go back?
So if you go back, let's say I go back, I close this and I'm here, then you just need to click this and you're there back again. Now you say you want to disable one of the metrics. That's what you can do with scope file. So if you go to the documentation, to the reference, in the scope configuration, in architecture quality, I'm so sorry with my throat. Okay, I see that option is not enabled for the user.
What I can say is if we can also follow up on this question over
Yeah.
email.
But I do know, like, we can disable one of the system, but maybe it's we do not want, because if we give this sort of freedom to users, that's something people can also misuse in a way. And therefore this is something, if we see for a particular case it makes sense to disable something, we can, like, we as an SIG can do it for you.
Yeah, but we will follow up on that
Yeah.
individually with the person who asked that question. So one other question that I think is interesting, because I do believe we have a good answer to that, but obviously, Kriti, I'm gonna make sure that I'm gonna answer to you. Is how is knowledge dimension measured? Specifically, when the presence of a developer can be very dynamic. So how do we measure knowledge, the sort of the knowledge components?
The knowledge distribution of the components. So what we do is, we basically, for the knowledge distribution, we need your Git log file. In the Git log file, we have your commit history. In the commit history, there's names attached to the people. We encrypt those names into some hash IDs, because we do not want to be reading who is working on which component. Every unique author is assigned an ID. And then what we look at is, in, let's say, previous year, this unique ID, in which components has it contributed. There are two things that we show in knowledge distribution, and I can probably use another system just to show you this. So we show total authors, as you can see. So here there has been no activity, therefore the total authors is 0. By default, we only look at last year. So in last year, for dev support, there was no unique authors. That's why you see 0. What we also calculate is what is the estimated average author. So how much has authors contributed to a component. So on an average, and the number of lines of code that they have committed to it. This is what we measure from the history, and this is what we have from our own benchmark number based on the size of the component. Now, if this is too much, that means we expect a lot more, whereas the things that are happening on that particular component is too less. We sort of penalize you for this one. So as you can see on the top two, this one is red, this one is also orange. That means you're doing worse than what we expect. The number of people working on that components are too low than what we would expect. Therefore, you get sort of bad ratings for these two ones. Whereas if this number, estimated authors, let's just make an assumption, would be 45 and we would expect 32. That means there are a lot more people working on UI portal than we expect, but we do not penalize for you, because in terms of knowledge, that is not a risk. It might be, let's say, crowdsourcing, as we say, that there's a lot of people working on a same component, which might also lead to risk, but at least from knowledge perspective, it is not a risk. We used to penalize in past for this, but last year this was changed, and now if there are more people working than what we expect, we don't penalize. If there are two less people working than what we expect, we do penalize.
Great. So that's one. Is there also another one that for the knowledge dimension? So does communication? I think that makes sense. So actually, I have a question on this. It goes a little bit. So last month we had one of our directors, Werner. coming on for the AMA to talk about technical debt. And one of the things he said is like, one of the things that he mentioned and he stressed specifically was to focus on technical debt in part of the system where you're actually still actively developing or maintaining or building. Is something like this, like the knowledge distribution, can that help there? Because it essentially allows you to see like, hey, where are our teams like making changes?
Yeah. So in that case, both these two metrics, which is combination of component freshness and knowledge distribution, helps you take insights. So what component freshness does is it tells you which are the active components. Let's consider in this case, this is a demo portfolio. You see most of things in green, most of things in red, which means not much is happening in these components just because it's a demo system. But if it was an active system, you'd see some components more active than the other ones. Maybe in your architecture, in a system, there might be a few components that you actively change. And then you know from the green ones that these are really actively being worked upon. And then if you look from here, which are the active components, and go into knowledge distribution just to check how many authors are working on those components. And if those are low, then you actually seriously have a knowledge risk because these are actively changed components, but maybe there's just one author making all those changes. And if this author is on vacation, you have a problem.
Yeah.
So this is sort of the insights that you can get when you combine data from different metrics.
Well, yeah. And if you then also see that from a maintainability perspective, so from a quality level, that same component scores relatively low. You also know that like, hey, we are making a lot of changes in this component. It's scoring relatively low. So if we actually like focus our refactoring here, we might get the best bang for our buck with regards to like actually speeding up our time to market and our value essentially that we are deriving from better maintainable code, right?
Indeed. And that's basically the same goes for maintainability. You can also look for the same component in security findings, in open source health findings. How are we doing with respect to there? Maybe this is an active component, yet we have, I don't know, licenses which are outdated. We are just generating technical debt for future.
Yeah. And I think that's simply something, you know, and that's where really the power of the platform and the power of the different models in combination comes, right?
Yeah, that's true.
Like looking at architecture in isolation is very interesting. Looking at maintainability and security in isolation can provide a lot of benefits, but it's really at these like cross interplays where like, okay, like where should we focus our efforts? Where like kind of like
exactly.
the hybrid becomes interesting.
And that's sort of these warning signals that I talked about. So when I was showing these 5 slides, I told you that, you know, the visualization itself sort of gives you a live documentation picture because we don't have it, and we don't, even if we have it, it's mostly not up to date. So this is sort of acts as a documentation picture. If there's something that goes beyond the architect role's expectations, you can always mark these lines and just discuss within the team, is this something that we expected or not? And then if now that you're sort of evolving this architecture, probably bringing more components in, you need to be aware of what these metrics are showing you. I mean, there are things where this architecture is pretty good at. Look at the code breakdown, data coupling, bounded evolution, code reuse, they're doing superb. But then if we look at coupling, we are already at red, which is fine if you want to scale it, but you always will have to keep in mind that the coupling was strong enough before. Maybe you want to loosely couple this, or maybe we want to change the architecture. Maybe you want to go to microservices because that would make the coupling go down. So these are sort of the question that you must ask yourself if you are in such a role, just seeing these warning signals. Hey, if this is a decision that I want to make, what are these metrics that impact or hamper my decision?
Fantastic. Thanks, Kriti. I already answered a few other questions, you know, like kind of offline. So like, are there other things that you would want to show?
Yes. So in recent time, what we have introduced is tracking changes. I mean, this one is not really an active system, which is why I chose this. What's upcoming, or what I think it's good to also tell you what's upcoming in this regards. People wanted to see changes in their architecture that has happened over a month, over 6 months. So now we have this time tracker here as well. Let me remind you, before it was always the last snapshot that we used to show, but now you are able to track changes to it. So you can select a time period, and then you see if there's a new dependency, then it shows up as new. If there's an existing dependency, but you added more lines to it, then it shows up as this arrow that, you know, you are increasing more increasing more dependencies here. In recent time, we have also made changes to this file tree. So here again, you see this blue dot means there are some dependencies that have increased in the compiler tricks. So these are sort of, and mostly from this file, that's where things are changing. If you go into the legend, in legend, you can see there are code calls, there are removed dependencies, and you see dependencies increased or decreased. You can expect a lot more things that are coming. For example, if new components are added, some components are removed and stuff. Although with architecture, if it is not an active component, not something in the young stage, usually things are stable and only dependencies are added, or maybe one or two components. But if it is more, let's say something that you just started new, it might be that you see, you pushed a change yesterday and you're able to track it with Sigrid the next day, basically. So yeah, this is basically it. You can expect more changes in the same, because our teams are still working on this epic. This is a huge epic just to show changes, to be able to track changes. You would also be, we are going to the level that once you click on these, right now it just shows you the source, target, and the count of these dependencies. The idea is to increase from here, also shows you which are the new ones, which are the dependencies that were added new, which are the ones that were removed, and you being able to also track, okay, this is the dependency and this is the part of the code where I added it, which is just going to make it more actionable for you, just like we have our maintainability model.
Thank you for your time, Kriti.
Mhm.
Thank you for everyone attending. If there are any follow-up questions, do feel free to reach out to us. You can reach out to your account team that you know, or to us directly. And hope to see you again in the next session.
Yep.
Goodbye, everyone.
Goodbye.